This is an algebraic simplification problem, but it has a twist of I. I is a complex number, right? And it is defined as the square root of -1. Now, you don't need to know much more about it than that in order to solve this. And what we're going to do is first we're going to take the left side of this and we're going to FOIL it. So let's do the first, right? So a times 1 is a. Outside, a times -I is minus ai. Inside is 1 times bi, which is bi. And last, which is bi times -I, which will be minus bi squared. All right, so we just FOILed the left side of that. It equals the right side of the equation, which is 2 minus 4i. And we can start collecting like terms. Now there's one little wrinkle in here, which is, notice that we have an I squared term. Well, since I is defined as the square root of -1, I squared will be the square root of -1 squared, which equals -1. So I squared is equal to -1, and you can plug that right in. It'll always be true, so you can just memorize that. You don't have to derive it like I just did. And what you'll end up with is a minus ai plus bi. So minus bi squared, this I squared is -1, becomes plus b, equals 2 minus 4i. So let's collect up our like terms, which means we're going to subtract 2 and add 4i to both sides. So the 2's on the right cancel out, the 4i on the right cancel out. And what I'm going to do is I'm going to gather up all the I terms, and I'm going to gather up all of the numerical terms. So what you end up with is a plus b minus 2. And now I'm going to factor out an I, plus I times, here's all the numericals, plus I times -a plus b plus 4. All of that equals 0. Now, here we need to do a little bit of jujitsu, which is they've asked us to solve for a. And what you can do is, now that we've separated this into the numerical component and the component that's multiplied by I, the jujitsu we can apply is, in order for this to be equal to 0, which they've told us is true, the only way that that can be true is if the numerical component is 0 and the I component is also 0. That's the only way that this number could be a full 0. So what you can actually set this up as the following must be true. A plus b minus 2 must equal 0. And also, -a plus b plus 4 must equal 0. Both of those statements must be true. Well, now we have a system of equations with two variables that can be combined and solved. Right? And what we want to yield a at the end of the day. So I'm going to rewrite these nicely. Say a plus b equals 2, using algebra to line it up. So I'm going to actually multiply this by -1, so I'll get a minus b minus 4 equals 0, or a minus b equals 4. So now I have two equations. I'm going to line them up. Right, take this one and just write it over there. I'm looking at this bank of system of equations, and what you can do with that is line it up, and let's add these so that we end up with an a. You'll end up with 2a equals 6, or a equals 3. So wow, that is a complicated question. You got to do a bunch of algebra. You got to see this trick that the numerical and the I component both must be equal 0. Set up the system, combine it, then solve for a.